In this chapter, you will further your study of kinematics by extending it to two-dimensional motion, wherein you will learn two important topics: vectors and projectile motion. So far, you have learned about several vector quantities, such as displacement, velocity, and acceleration. In upcoming chapters, you will continue to learn about more vector quantities, including force and momentum. A vector quantity can be graphically represented by using arrows. The length and direction of an arrow can be changed to vary the magnitude and direction of a vector quantity. The motion of an object in two dimensions will be represented by drawing vectors, showing the independence of horizontal and vertical components from each other. You will graphically add and subtract vectors using what is called the head-to-tail method, also known as the tip-to-tail method. Drawing a resultant vector when a given vector is multiplied by a positive or a negative scalar will be explained. Analytical methods, which are more concise, accurate, and precise than graphical methods, will be used to determine the magnitude and direction of a resultant vector when vectors are added, subtracted, or multiplied. You will learn about component method of vector addition and subtraction. The concept and representation of a vector in terms of unit vector notation will also be explained. To learn projectile motion, you will extend your study of free-fall motion to include the motion of an object in two dimensions. To understand projectile motion, you will identify and explain its properties, such as acceleration due to gravity, range, maximum height, and trajectory, meaning the path of the projectile. Since projectile motion is the motion of an object in free fall, constant acceleration equations will be used again to determine various physical quantities like location and velocity of a projectile at different points in its trajectory. Following the principle of independence of motion in the horizontal and vertical directions, you will have to be cautious when using constant acceleration equations and be careful not to mix the kinematic quantities from motion in the x direction to motion in the y direction and vice versa. This can be achieved by clearly attaching the x and y subscripts to constant acceleration equations, which is one of the problem-solving strategies to solve projectile motion problems. To strengthen your problem-solving skills, strategies will be discussed for choosing correct constant acceleration equations and various conditions to be considered when determining an unknown quantity. To further reinforce these concepts, several demonstration videos of the two-dimensional motion of objects will be utilized.